Now, and after that, there is also, whenever you run the program, right, sometime, I'm not sure, you will get something called as a seg fault in your program, where you know that something has failed, but you will get a seg fault. Okay. So now our thing is, and you will get something like this. You'll get seg fault. Let me see if I have a program as an example, or else we'll create one. I have a program. So see this program. Okay. So now see this program. Oh, what happened? Make clean. I didn't go. Okay, that's fine. So look at this program. So what is the problem in this program? What is the problem? Is there any problem in this program or not? Is there any problem in this program? If you look at this.
We are directly assigning 10 to the address, and that address does not have allocation.
Okay. Yeah. So not allocating, if you see, right, you're accessing a memory 12 and you're trying to modify something here, which is not correct.
Yeah.
Okay. So now if you see here, this is not the correct thing. Okay. Then this will relate it to crash. Okay. For that reason, okay. So for that reason, we have to, this will lead to memory corruption. Okay. So I will run this program. We will look at it. Just give me a second. Seg fault. Oh, sorry. I think I've not compiled it. Let me see. I will run this program. Seg fault. Okay. Now, if you look at the D message, no, see, you will get the message something like this here. Sometimes you'll get a, this is called a seg fault. You'll get a seg fault, but you don't know why it has failed. And what is the reason for the failure? Okay. So that kind of information is missing. Missing in the sense we have some cryptic information, but our goal is to figure out what exactly happened here. For that, so now we look at how to decode this information to figure out what exactly has gone wrong in the program. Okay. So now whenever you get this issue, right, the first line information is very important. It will give all the things. First, it will give the process name and what is the PID of the process that created this issue. This is what you get from the first line. First line, in the first two columns, you get this process name and a PID. Then after that, again, if you look at it, again, you will get the process name again. Okay. You will get the process name again. Okay. So you will get to know what is the reason. It will tell, sorry, this will give the reason for the failure, segmentation fault. It is telling the issue of segmentation fault. At which address? So while doing some operation at a memory address 12, the corruption occurred. That is the kind of information you will get. Okay. So in this case, it is the error occurred while manipulating the memory address at 0. Okay. So for example, if you see here, this example you see closely. Here I was manipulating address 12. That is the reason this issue occurred. So now let us assume I will put 15. And I will compile it. Now, if I run it, see here, the address which is manipulating is 12. And if you see here, the instruction pointer at the time of the crash is this. This is an instruction pointer at the time of the crash. We got an instruction pointer at the time of the crash. This is something that is important. Now we got another stack pointer at that time. And there is one more line which tells what was the error at that time. The error is 6. So now to figure out what is that error 6. Okay. So now error 6. Okay. It maps to this. It's nothing but a bit field. and each bit will correspond to some different issues. Okay, so in this case, the error map is 4, and if I do equal to binary, it will come as 0, 1, 0, 0. Okay, so in my case, wherever the issue is happening, the code is 6. Okay, so since the code is 6, I will get something like this: 0, 1, 1, 0. This is the value. Okay, so now if I go to this bitmap and check out what is it. Okay, so bit field 0, it's not a page, not fouled issue. Bit number 1, it means that read access means some issue to do with the, sorry, if it is 0, it is a read access, 1 means read access, write access. In this example, whatever is present in the PPT, the error happened because of the read access. In my case, it happened because of the write access. Somebody is writing to that memory. So this field, bit field, will indicate that somebody is not reading from the address 12, 15, whatever is showing there, 12 or 15. It is telling that somebody is writing to that location. Okay. Now, in which space? Is it in the user space or is it in the kernel space? One indicates that this operation is happening in the user space. So means this fault happened in the user space when you're in the user space, not in the kernel space. So now with this, I get to know with this bit field like 6, I get to know that, okay, the issue happened because somebody is writing to address 15 and this address writing happens in the user space. This is something which I get an information. Okay, so there are a lot of other bit fields. These are the main bit fields what we get from this mechanism. Okay, so now if I decode this, so look at here closely. If I decode it, I will get to know the process name. I'll get to know the PID of that. Then I'll get to what is the reason. Then I'll get to know which address the issue occurred. What is the instruction pointer at that point of time? And what is the stack pointer at that point of time? What was the error? 6. 6 tells that somebody is writing to this address. And then the issue was this issue occurred in the user space. Then after that, it tells that this program segfault, if you take this program segfault, from this particular, it tells that this is the address where this program is starting from. Okay, and this is the length of that instruction. This is the size of that. It is telling that wherever the issue occurred, right, the code segment start at this particular address. So there's a function called segment. In the segmentation fault, there is some code segment. In that, the size of that code is 1000. This is the information what I get. So the size of the code is 1000. So means if you subtract this from this, I get an offset of 165. Okay. So at the start of this particular offset, at the start of this base address, wherever it starts at this base address, wherever the code segment starts, the offset of 165 of the code segment, the location of the failure is there. That is what I get to know from this particular location. Okay. So there are a lot of ways of doing it. One such way is, and if you see this, right, this is the code pattern where the issue has occurred. And this is the exact place of that code pattern where the issue has occurred. You can do an XDump. You can find this code pattern. You can go to that code pattern and you can figure out the exact place of an issue. That is one way of figuring it out. Okay. So if you see this thing, right, what I do is using GDB, I find the pattern. And from that pattern, I will find a kind of an SCD logs. Okay. From that SCD log, I'll find this pattern inside my code using GDB. This is one thing what I can do in my program. Okay. So this is something I can do in my GDB program. And if I do it, I will get the location where the issue is occurring. This is one way of doing it. Okay. So I will just show you what I will do is I will take this code. Just see this. I will take this. This is how to find the, I have to find the pattern. Okay. So to find this pattern, I have to get this thing. So what I will do is I'll copy this. Okay. So now I have to introduce the code pattern to this. So I will take this code pattern. So let me show you what I will be doing here to figure out this issue. Okay. Just give me a second. This is one way of finding it. I have to find this instruction sequence. Where does this instruction sequence occurs in my code? This is one way of doing it. Okay. So now if I do this, just give me a second. Just a second. I know what is the problem. Yeah. So I will get something like this here. I'll get the sequence something like this. I've got an output. So this is one way of finding it. Now what I have to do is I have to start GDB of that program, which is creating the issue. And then I can look for this pattern sequence. Where does it occur? Okay.
Find is the GDB command, right?
Sorry?
Find is the GDB command.
Yeah. Find is the GDB command, but
Okay.
I have to enter the start address and the end address. Okay. So for that, if you look at here, what I have to do is I have to find the start address and the end address. I need to figure out where it is. Okay. So what I will do is just give me a second. Break main run. Okay. So then after that, you have to get the break. You have to get the sequence. I will tell info targets. It will give me all the information. Okay. So now if I do info target, okay, it will give me a lot of addresses here. These are all the address location where the program has been available and residing. Okay. So for me, this is the program address, what you can see. So what I have to do is in this, I have to take the address. For example, where is the touch segment available? I have to take that. Okay. So in my case, I have to find out where the dot segment is available, wherever the code segment is available, right? That I have to take. And that is a very important part of my program to figure out what exactly is happening. Okay. So I will look for dot code wherever dot code is available.
Here I saw dot text.
Yeah, dot text. That is the one. So I have to take the dot text. Okay, so that is very important part. Wherever the dot text starts, right? I think the dot text starts from this address. Init is the place where the real text segment would start. I have to take this thing, okay, and I have to give this pattern till here to the end of the code segment, wherever the code segment starts, right? I'll give some 1000 as a sequence. That's fine. So what I will do is I will take this, and then I will go to home. I will give one range here, telling that this range to this range, you look for this particular code sequence. Okay. So now let me give 600. Yeah. It gives an exact location. One pattern got found. Okay. So the pattern got found at this address. I will tell list of this address. Okay. So normally, so now if you see that this pattern is found on some particular address, if you figure out the code list should come, but currently it is not coming, that is also fine. Or else I can also do with an offset 175. It should come.
What does star means? Because I skipped 2 classes.
Star is an address actually.
Okay.
So print the content of an address. So wherever you see, what you can do is whenever you want to list, right, you can tell, you can put this address. At this address, it has to open. Okay. So now if you see here, it tells where the
dereferencing.
Sorry.
Star is dereferencing, like C.
Yes, star is dereferencing. Okay. Yes,
it's
like a star is like a normal C only. Okay, so you can dereference and you can figure out where, what, and where it is happening, and all those you can figure out. Okay, 175 or something you can see. So like that you can do it. So all those things you can figure out and you will get the addresses. Okay, so or else what you can do is, since we know that it's from the base of this address, it starts at 175, right? So what you can do is you can take this address. That is also one way what you can do directly, because that is what you can see from the code. Okay, so instead of doing that, I can go to this code, to that exact location, paste it. Okay, then plus 175 you have to put. Oh, what happened? So text segment, 1 minute. Let us put the exact calculation, because it starts from here 175 from this. Don't know why exactly it is not showing. Using that, we should be able to see it. But this is how it is. Actually, you should have found, but I will show you one easier way to find out. With this, you should have found out, but there is one thing what I can do. You can do an object dump of this. Okay. So now you can take this example, segfault. You will get this data. I will put it to segfault.obj. You can go to this segfault.obj. Okay. Now this, if you see, right, you have to go to this offset where the init starts. That is a place where the program would correctly start. Okay. So if you go to this init, It is go to init. From that offset, the program would start. Okay, because that is the point where the program is really available. Okay, so now just give me a second. We will go to init because that is the first entry point of your program. Yeah, so this is the first entry point. Okay, so now from this 175 is what we see, because that is what you can see in the segmentation fault. If you look at the seg fault, right? Let me show you. Sudo demessage. Okay, so if you see here from this, sorry, it's 165. Sorry, if we have to subtract this, if you see this, right, it's nothing but 49495 E, and it is nothing but 165. Okay, so you should go to this offset called 165 to get the correct information. Okay, so from that offset, if you go to 165, so if you go to this 165, so it is almost there. Yeah, see here. Yeah. So if you see this, right, from this offset 165. Okay. So if you look at this offset 165, that is nothing but this location, and this is the point of crash. Why? See here. In this location, you're first putting address 15 and you're dereferencing that address 15 with a value A. And you can see exactly at this point it is crashed. And that you can get from this. Okay, from this location, you can get the information how exactly it is crashing. You see here, you're able to get the information. Sorry, previously I put 175. That is the reason it was going somewhere and it was trying to print the information. That is the reason we didn't have the proper thing. So this is the correct location. Okay, so now if you do same thing via GDB, just give me a second. So I will tell break main, you run this program, and once you run it, okay, or you can do without running also. Exit, we can do without running also sometimes. Break main. What you can do if you don't run it, right? You should tell list star 165 0x165. So it should have, but you should look info. We should look at the information. Okay, because we need to look at all the information of this stack, like info target. If you do right, it will give all the information. So if I tell info target, this is the location, and you need to look from init. Init is this location. I have to take this. Okay. So now I have to tell list star 0x165. This is the location. And you can see here, it gives. So it is telling exactly that go to line number 7. Line number 7. This is the place. Okay. So it gives the correct location.
This
See here?
point is not clear.
Sorry?
It is 165. 1165. Why?
No, it's 1165 only. It is not 11 is because we need to take and start off an init. It'll have a lot of segments here, interrupt section, note section. These are all the debug information.
In message, it was, I think, 165.
No. It was not 165, I think. It is 1165 actually. 165 because it's taking the code segment actually.
Okay.
See, whenever you see this D message, right? It was 165, but with respect to the code segment. It is instruction pointer, right? Instruction pointer will execute from where? From the code segment. Okay. So now starting from init, it is nothing but 165. Okay. So now we need to figure out where is the init segment. That is the reason we do info targets to find out where the init, the text, the correct executable will start from. Okay. So the correct executable will always start from .init.
Okay.
You can check out if you put a breakpoint at.
So you added 165 to 1000, right?
Yes.
Okay, then we get 1165, right?
1165. That is the thing, because you should always look from the init. Always your execution starts from init, and so this will show that 165 from the load of basically from the segment actually. Okay, so I check from init and add 165, so I go to the correct location.
Okay.
Or else you can check out if you have a correct mapping to your text segment, right? You can look from there also. Okay, so basically I need to get the correct offset where my segment is present.
Okay.
Got it, right? Because most of the time it starts from here. So that is the reason to this I add 165 so that from this offset, it will go to the correct place and you will get all the information. Always it starts from underscore init. That is the reason we debug from underscore init.
Got it.
Okay. So that is the reason we add, always we take a reference from init. So we find an offset from init, and to that we add whatever address it is, we add 165 and we get it. For example, if I run, now info target will change because relocation of address will happen. when it runs here. It has relocated and everything has changed to this address. Now I have to take this address. Okay. So now if I take this address, I should tell list star this address plus 165. See here? Got the thing?
Yeah, got it.
Yeah. So always you should take on .init as the reference.
So on relocation will actually point to an actual memory location?
This is a virtual address, not actual memory. This is a virtual address.
Okay.
So before that, it was not virtual in nature. It was whatever was visible as a part of an object dump, right? That it was showing, because the remapping was not done. When I told run, the program started running and the virtual address changed. It relocated everything. All the segment it relocated into different location inside your virtual memory address space. And that is what you will see. And this is the virtual, in this virtual address space, this is what is available. And that is what I'm seeing here. Okay. Yeah.
Yes.
Yeah. So this is something which we should be aware of. Okay. So like this, we'll be able to debug and figure out where exactly the segmentation fault has occurred. Okay. And how exactly this segmentation fault can be decoded. Okay. So this example shows one of the example where we know whenever the segmentation fault occurs, how we can decode. So these 2 lines is sufficient for me for debugging. That is what I will get from this thing. Okay. These 2 lines gives me the complete picture. Okay. So these 2 lines has a complete information as I mentioned in this example. Okay. Yeah. So that is the reason. So by seeing this 2 line, I will get to know where it is failing. Okay. So that is something which you have to decode as per this table and figure out where it is happening. So since it is very important, I just wanted to stress this example. Okay. So you people might be facing multiple times in your production environment. You just follow this rule. You'll be able to decode and figure out what exactly is the issue in that particular scenario. Okay. Okay. So this is about segmentation faulting. Okay. So now we look into a concept called process management. So before I get into this, any questions from the previous parts?
Yeah, I have a question.
Yeah,
actually, means I got and means during the interview, one question was asked from me. Means there are suppose 100 files. So
100?
Suppose there are 100 files or 100
okay.
functions. Maybe it is a huge code. So there are suppose there are 100 functions. So one function is being called by 50 functions.
Okay.
So if there is a means issue in the function that is being called inside 50 different functions. So if there is a crash dump or core dump, means if there is a crash, so how to find that? Means we know that this function is causing the issue, but which function call is means which function calls that function? How to know that?
That is what. See, for example, let us assume that first of all, we should have this core dump. Okay. So if, for example, see, we took the core dump. Okay. So let us assume, okay. So let me do one thing. Okay. So GDB of that core dump. I think we took a core dump of test. Okay. Core 1. Okay. Now we got something like this. I will look at a backtrace. Okay. So backtrace will give me the complete information, how the flow happened. For example, let us assume that the endpoint will always be the function of the failure. Okay. You will get to know which function called that function. That is something you will get. Okay. But if this is a single threaded application, okay. But if it's a multi-threaded, okay. So you have to look something called as info threads.
Okay.
Okay. Then after that, you have to shift to that thread. For example, let us assume there are 2 threads. I have to give a thread number and shift to that thread. Then I can look at call stack in that thread and figure out where it crashed.
Okay.
Okay. For example, if there is a multiple processors, that also you can look at it. Okay. So for that, you have to look. There is an option called info. Just give me a thing. I think it is called info exception. No. It is not inferiors. If you look at info inferiors, right, it will give which process it is causing. Okay. Then you can go to that process and figure out which process is causing it. Like that, you can do it.
Okay.
Okay. So everything is possible. So once you get to know which function has created a problem, you'll always get to know that function is a problem. That is true, right? Because that function is a problem. Now you have to look at all this backtrace. You have to look at all the things. Okay. Then if once you get the snapshot, right, you can debug and figure out what is going on at each and every point. That you can do it by GDB. It's possible. Yeah. I hope I did answer your question.
Yeah, got it.
Try that. Actually, you simulate this the way you, whatever example you showed, right? Simulate something like that in the code and try to see this here. You will get to know once. You try that exercise. I would recommend you. Okay. Then if you want, we can discuss once again with that. How is it useful?
Anand, but in this example, you are running the GDB to get the process ID. So that means you have to run each application to get the process ID, right?
No, here I don't need a process ID. I just need the core file, actually.
For every application, you need the core file. I mean, to
yes, you need a core file. Yes, otherwise, how will I know what is the what is the problem in my program? Either I have to see the log, which I have you introduced in my program. If I've introduced the log in my program, I have to look at that log. Or else I have to look into the message like there are something varlog messages. I have to look at varlog messages. I have to look at the D messages. Or if there is a core dump, I have to look at the core dump. Else I will not be able to figure out, right, what happened into my program. Provided it has crashed. If it is hung, immediately I can connect to that via GDB and figure out what is going on internally. That is also possible. Okay. Yeah, but you should have something. Without that, you can't debug. You need some entry point. That entry point could be a log, it can be a core dump, it can be a running process, so attaching via PID. You can do whatever you want, but you need some entry point to debug, else there is no possibility of debugging. Okay. Yeah, got the point?